All right, now let's have a look at the practice problems of this handout. We're going to be looking at 2 and 3 on this side, and we'll look at the rest later. So here we have a rectangle. We gave you 3 points of the rectangle here, A, B, C, D. This one is particularly large, but I guess that's okay. And we want to determine the area of A, B, C, D. So I guess we're going to sketch this out here. So I'm actually not going to put axes in here, but it should work out nevertheless here. We have A at 6, -26, and -22. B is going to be over here somewhere at 2006, 178. Now, obviously, this is not drawn to scale. You'll have to forgive me for this. Now, because it's ABCD here and it's going in this direction, we know that D is actually going to be down here, and we're told that there's going to be 8, y for some integer y here. And then C is going to be somewhere over here. So we can go ahead and sketch our rectangle here. Here's our point C. Now, we don't know where it is, and frankly, it doesn't really matter here. So now let's try to figure out what's going on here. Knowing that this is a rectangle, we know that all the angles are right angles here. So that means in particular, this is a right angle here. So we can use that to calculate the value of y, right? So in something like this here, we can calculate, in this case, we can look at the slope of the sides. So for instance, the slope of AB here, we can just go ahead and calculate this. There's going to be 178 minus the other y coordinate, which is -22, all over 2006 minus 6 here. Now this actually works out really well. 178 minus a -22 is actually 178 plus 22, which is 200 over 2000 here. That actually gives us a 1 in 10. So our slope is 1/10 here. Now we know the slope of AD. Well, let's see. Because this is perpendicular to AB, we know that the slope has to be the negative reciprocal of 1/10, which in this case is -10. And that is going to be equal to, so we can go ahead and set this up here, y minus a -22 all over 8 minus 6. So we know that -10 is equal to y plus 22 over 2. So -20 equals y plus 22 here. So you get y equals -42. And that's a useful thing as well. So now we know that this is located at 8, -42. Now, this is a rectangle. So the area of the rectangle is very easy here. It's just the length times the width. So it's just a matter of AB times AD here. So I just got to figure out what AB and AD are. So now we can use the Pythagorean theorem or, distance formula here. We can go ahead and set that up here. So AB in this case, again, is going to be x. So let's see, we're going to compare the x coordinates. So it's 2006 minus 6 squared plus 178 minus a -22 all squared here. So this is going to be the square root of 2000 squared plus 200 squared. Now, before you actually do the calculation here, we know that in this situation, there's a 200, so 2000 is really 200 times 10. And there's 2 copies of it because we have 2 copies of 2000 here. So I can actually yank that out. I'm actually going to pull out a 200. And I'm actually going to pull out 200 squared from both of these here. Now, when you do, it's pretty clear that this 200 squared just becomes 1. Here, note that 200 is a tenth of 2000. But since there were 2 copies of it there, I'm pulling out 2 copies of 200, leaving the only 10s behind, and there are 2 copies of it. So it should be 10 squared. Therefore, AB is going to be 200 times the square root of 101. Okay? Now, for AD, we can do much the same thing here. We do our calculation for AD. So in this case, AD is going to be the same idea here. So it's going to be y minus -22 all squared plus 8 minus 6 squared. Now you'll note that I'm switching the x's and y's. That's okay. It really doesn't matter here. So this becomes, so this y plus 22 squared. Now we know y is -42 actually, so I guess I should put that in here. So -42 minus a -22, that's -42 plus 22, so it's a minus 20 all squared plus 2 squared. Now, minus 20 is really, minus 20 squared is 400, so you have 400 plus 4. So this is the square root of 404, right? And in this case, we can find it here. We can yank out a 4, and we're left with 2 radical 101, okay? So therefore, we can now calculate the area. The area is just the product of these, 200 radical 101 times 2 radical 101. Now, 200 times 2 is 400, and 1 times radical 101 times radical 101 is just 101 here. So you have 400 times 101, which in this case is 40,400 here. So you find that the area is 40,400. Okay, problem 3. Now this is a bit of a strange problem. You don't expect to see this in a chorded geometry problem, but let's give it a go anyway. We're going to sketch this out so we can draw our triangle like so, right? So here's a triangle. AB is 8, BC is 12, so B is here, here's C, here's A. This is 8 and this is 12 here. And we're told this is 30 degrees. We want to find the length of AC. Now, generally 30-degree angles are really nice here. So if we were looking at this in just a traditional way here, we can go ahead and drop, we can see that 30-degree angles look really, really nice because they pair with 60s very well to create 30, 60, 90 triangles. So we can go ahead and drop an altitude, I'll call it AD. This is 30, this is 90, therefore BAD is 60, and therefore we have a 30, 60, 90 triangle. So that means AD here is 4, and BD here is therefore 4 radical 3. Knowing that BC is 12, we can now calculate DC here, and this is just going to be 12 minus 4 radical 3 here. Okay? And now I've got a right triangle ADC here, so I can use the Pythagorean theorem. So we can write this here, and we say that AC squared equals, in this case, 4 squared plus 12 minus 4 radical 3 all squared. Okay, that's going to be kind of ugly, but let's give it a go anyway. That's 16 plus, let's see, 12 squared. So we know there's going to be a 12 squared. 12 is going to be multiplied by itself, so there's going to be a 144 here. Now, there's a cross term here of 2 copies of 12 times 4 radical 3, so 12 times 4 radical 3 is 48 radical 3, times 2 is 96 radical 3, so we're going to have a minus 96 radical 3, and then we're going to have a positive value of this at the end. We're going to square this, so that's 16 times 3 or 48. Okay, and then we can put this together. 16 plus 144 is 160. 160 plus 48 is 208 here, minus 96 radical 3. So therefore, AC is just going to be the square root of 208 minus 96 radical 3. Now, this is not a very nice number, but we can probably simplify a little bit. In particular, I notice there's a 4 in common to both of these. And in fact, you can actually do both. You can see there are actually 2 4s in this. There are 16s in both of these here. So we can yank out a 16. And when you do, when you yank out a 16, you're going to have a 13 minus 6 radical 3 left over, right? 208 is 16 times 13, and 96 is equal to 16 times 6. So that means this at the end should be 4 radical 13 minus 6 root 3, all like this here. Now, why did I give this problem here? Why did I do something like this? It has nothing to do with coordinate geometry. But in a way, you can think of this as something to do with coordinate geometry, because this here, this is actually very well known amongst math team people. Note that in this situation, we can very easily do this problem. If you choose not to do this with geometry, you can do this with algebra. In particular, this is a very gentle introduction to what we sort of affectionately, some people call it affectionately, some people sort of derisively, they call it coordinate bashing, where basically you take this entire thing and you put it in a coordinate grid. So we can go ahead and sketch this out here. And we're going to sketch the triangle, but this time put it in a coordinate grid. So in this case here, it makes sense for us to put point B at the origin, so we're going to call it 0, 0. And I'm just going to redraw the triangle, so now it's in the coordinate grid like this. Here's A, here's C. So we can basically do much the same thing here. We know this is 8 and this is 12 here, so C is going to be at the point 12, 0. And now we just define the point A and then just finish the problem here. So in much the same way, we can go ahead and sketch the drop our altitude here, do this. We know this is 4 and this is 4 radical 3 here, so that actually tells us where point A is. It's going to be at the point 4 radical 3, 4. And now we can use the distance formula to finish it. We know to have AC is the square root of, let's see, it's going to be 12 minus 4 radical 3, all squared, plus 0 minus 4, all squared. And you'll note that this is, again, actually, this matches exactly with that, and there's no accident for this here. So you can see that we can do much the same thing, do the calculation again, and we end up with exactly this here, 4 radical 13 minus 6 radical 3. So, so there are certain situations where if you don't like a problem as it is right now, you can convert it into an algebra problem. All right, now let's look at number 5. We're going to finish it up with number 5 here. So number 5, we're given some information about some points here, and some points A prime, B prime that lie on this line. So I'm going to go ahead and sketch this out here so we can see this a little bit better. Granted, again, my picture is not going to be very nice. It's not going to be to scale, but that's okay. I'm sure you can figure it out here. We have a line y equals x, so I'll sketch it in here. Here's our line y equals x, like so. Okay, so we're going to label our points. So here's going to be 0, 9, and 0, 12 here. So here is going to be, so I'm going to put B up here. There's going to be 0, 12. And then 0, 9 is going to be about here-ish. Okay. Now, we are told that they intersect at the point 2, 8. So let me go ahead and sketch 2, 8 into the picture here. So it's going to be something like this. So here's our point 2, 8 here. So note that in this situation, the segments A prime, and B prime intersect at 2, 8. So that means I can draw a line like this through B, through here, and it's going to hit over here. This is going to be our point B prime. Similarly, I can do the same thing over here, sketch a line like this through these two, and here's going to be my point A prime. So now it's just a matter of figuring out what the coordinates of these are. So we can just do this one at a time, right? We know that AA prime, well, let's see here. The fact that A and B are on the y-axis is really nice here. So we can actually calculate the slope of this, the slope of AA prime. And the slope of AA prime, let's see, that's just going to be 9 minus 8 over 0 minus 2, which is 1 over minus 2, which is minus 1/2. So therefore, we know that AA prime here, since we know the slope is negative 1/2, and it passes through point 0, 9, we know the equation that it's going to be y equals minus 1/2 x plus 9. And we know that this point, that this is the line y equals negative 1/2 x plus 9, and it intersects the line y equals x, which means I can just swap y for x here and do that. We get x equals minus 1/2 x plus 9 here, because we know that this point lies on y equals x, so y and x are interchangeable. So we can add half x, so we get 3x over 2 equals 9 here, and therefore x is equal to 6 if I'm not mistaken. So that means here we know that this point is going to be 6, 6. And we can do much the same thing over here with BB prime here, right? BB prime, we can do the same thing here. In much the same way, the slope of BB prime here is going to be, in this case, 12 minus 8 over 0 minus 2, which is 4 over negative 2, or negative 2 here, right? So therefore, the equation of BB prime is going to be y equals minus 2x plus 12. And again, we know that this is on the line y equals x, so we can swap each for each other. X is equal to negative 2x plus 12, and you get 3x is 12 and x is 4 here. So that gives you that this is the point 4, 4. And then, you know, you can just finish the calculations here. You can do the Pythagorean theorem or distance formula, whatever you want to here. Just sketch this out. We see that this is 2 and 2 here, so it's pretty clear that A prime B prime here is just the square root of 2 squared plus 2 squared, which in this case is the square root of 8, or 2 radical 2.